Okay, now we're going to dive into section 12.3, partial derivatives. F prime at x, if you remember from 2-space, when y equals f of x, f prime at x, or the derivative of f with respect to x, is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So it's the limit of the difference quotient. We also called this df dx is one thing that we called it. We also called it different names like the derivative of f with respect to x. We use a capital D of f with respect to x. So these were some notations that we used. And of course, if we have f of x, y equals f of x, then we also had notations like dy dx would be another one, another notation for derivative. And of course, all of these are equivalent to the slope of the tangent line at any point x. So really, if you remember back on page 114, when we had a particular x value, they used x sub 1. Well, f of x sub 1. So they use this x sub 1 for a particular x, but then we could use it for any x. So eventually we drop the sub 1. Well, you're going to notice in this section that they turn that sub 1 into a sub 0. So it's kind of crud that they, since I'm being recorded, I can't use bad words. So it's kind of crud that they don't use for a particular point in 2-space. We have f of x, y, and if they want to look at a particular point, they're using f of x 0, y 0. But if they wanted to really match what they did back in section or chapter 2, they would have actually called that particular point f of x1, y1. But anyway, hey, we're not going to worry about inconsistencies in the book because I didn't write it. They can't pay me enough to do that. So anyway, let's go to really the multidimensional aspect of this. And so really what we're going to do is we're going to take the derivative, of partial derivative of f with respect to x. So we're gonna basically talk about it in two parts. So the partial derivative of f with respect to x, I got to get where I can write again. The partial derivative so the first one is of f, but it's f is in two variables, f of x, y, with respect to x. How are we going to define this then? This is going to be defined as, once again, the limit as delta x approaches 0 of f of x plus delta x, just like before, but it's actually of two variables, so comma y minus f of x, and then comma y all over delta x. So very similar to this, but what we're going to do is we're going to say this is the partial derivative of f with respect to x. So instead of saying f prime, what we're going to do is we're going to say a couple of different things. We can call this the partial, instead of df dx, we can say the partial derivative of f with respect to x. So that's kind of a funny looking d. Really what I do is I don't bring the leg down on it, so I kind of make it like a backwards 6. So it's a curvy looking d. So the partial derivative of f with respect to x. So that is one notation for a partial derivative of a function in two variables with respect to x. Another way we could do this, instead of, we could use a capital D like we did before. So it's capital D sub x of f. But also there's two variables here, x and y. So of course x is the first variable. So another notation that we could use is d sub 1 of f. And then another notation would be, instead of f prime, we could say f sub x, So that'd be the derivative of f with respect to x. And of course, the variables are x and y. So what we're going to do is we're going to treat y like a constant. So we're going to treat y like a constant on this. And that's the partial derivative of f with respect to x. So now we can look at, very similarly, with respect to y. So if I do that, let me just clear this off. All good? Okay, thank you. Have fun on your trip. You can have this. You might need it for calc too. Yeah, I would like that. I'll give it back to you in calc too. We'll get something worked out. Yep, see ya. Okay, so now we're gonna say the partial derivative of f with respect to y. Got to get where I can write again. Partial derivative of f with respect to y, we can put notation like this. We could also say y is the second variable, so d sub 2 of f, and then we can say the derivative of f with respect to y, d sub y of f, or we could say f sub y. So these are all notations for the partial derivative of f with respect to y. So anyway, long story short, what is that partial derivative of f with respect to y? Sorry, I don't want a squared off either. I want a curvy one. Anyway, this is going to be the limit as delta y approaches 0 of f of, now in this case, x is fixed, and then it'd be y plus delta y minus f of, oh, come on. Well, it's not letting me write anymore. So let me go back, try and go back in. Come on. Oh my goodness. So close this out and then come back in and hope I can get there. Oh my gosh. So I'm back in. I'm really thinking that it didn't let me talk that whole time. Like, I don't know if I re-enabled my voice the last time. So I'm going to do this. I'm going to try and do this. I think I'm going to leave it and come back to it because I got to see if I actually did that. Instead of working through this now, if I didn't have voice in the middle part of this, I'm going to have to redo it. So not really looking forward to that. But anyway, so that's good for now on this. Go ahead and try and figure this one out. I do have it in the notes and it's also in the book. But, we want